4.6 Day 2, we're looking at some homework examples. So for example, solving and then also even and odd functions. So these are just some examples for homework number 49 through 56. Now in the homework, it'll focus on the secant, cosecant, and cotangent, but just to kind of introduce you to, how to solve, we're going to take a look at other functions, sine and cosine, for example. So find the solutions of the equations in the interval negative 2 pi to 2 pi. So 2 periods. So when does cosine of x equal 0? That's what we're trying to solve for. We're trying to solve for what is x. So when does the x value equal 0 on the unit circle? So we can think about it. X equals 0 here, and it also equals 0 here. So those values are at pi over 2 and at 3 pi over 2 on the unit circle. So pi over 2 and 3 pi over 2. Okay, that's where x equals 0. Then we have to go backwards and figure out where it is from negative 2 pi. So one way to figure this out is you just take pi over 2 and then subtract 2 pi from it. Do the same thing with 3 pi over 2. Subtract 2 pi in order to get the coterminal angles for those. So let's see. Pi over 2 minus 4 pi over 2. That is going to be negative 3 pi over 2. Then the other one, that would be also negative 4 pi over 2, so that is negative pi over 2. So the answers are x equals negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2. For B, when does sine of x equal positive 1/2? Positive 1/2. That's going to be here. So y is positive in quadrant 1 and quadrant 2. And 1/2, that is where? Well, that's at pi over 6. And then on the left side, we can figure that out. Pi minus pi over 6, that is 5 pi over 6. We have those two values. Now we have to find the ones in the negative side, so negative 2 pi. So we were going to take 2 pi, we're going to take these and subtract 2 pi from it. So pi over 6 minus 12 pi over 6, that is negative 11 pi over 6. And then you do the same thing for 5 pi over 6 minus 12 pi over 6. So that is negative 7 pi over 6. So the answers are negative 11 pi over 6, negative 7 pi over 6, and pi over 6, and 5 pi over 6. Okay, the last one. So secant. So this is good to look at. So secant of x is root 2. So I think about when does cosine of x equals, so it's the reciprocal, which was 1 over root 2, and then we rationalize the denominator, so root 2 over 2. So we want to look at when does cosine of x equal root 2 over 2. It's the same as secant of root 2. So that is going to be in quadrant 1 and quadrant 4, so I know this is pi over 4. Now to figure out the other one, I just think about 2 pi minus pi over 4, and that gets me the positive one, so that is 8 pi over 4. That's 7 pi over 4. Now to find the other ones, we need to do pi over 4 minus 8 pi over 4, so minus 2 pi. So that's negative 7 pi over 4. Then we take 7 pi over 4 minus 8 pi over 4, and that is negative pi over 4. So the answers are negative 7 pi over 4, negative pi over 4, pi over 4, and positive 7 pi over 4. So try these three examples here. Sine of x equals negative root 3 over 2, cosine of x equals negative 1/2, and tangent of x equals negative root 3. All right, if you try this out, sine of x equals negative root 3 over 2, so that is in quadrants 3 and 4. And I know that because the x value is larger, that's going to be a multiple of the 3. So 4 pi over 3 and then 5 pi over 3. And then, so I got my answers as negative 2 pi over 3, negative pi over 3, 4 pi over 3, and 5 pi over 3. From number 2, when does cosine of x equal negative 1/2? So sorry, the equal signs are missing here. When does cosine x equals negative 1/2? And negative is when it's in quadrant 2 and 3. So that's 2 pi over 3 and 4 pi over 3. Then when you find the coterminal angles for those, it's negative 4 pi over 3 and negative 2 pi over 3. For number 3, tangent of x equals negative root 3. So you have to kind of think about that a little bit. We know that tangent equals negative root 3 when I have root 3 over 2 over 1/2. So I'm looking at when y is root 3 over 2 and when x is 1/2. Then it's negative, so I think about ASTC. For s, that is positive, so it is sine is the only one positive, so I know for sure tangent is negative in this quadrant, and it's also negative in quadrant 4. So again, it just happened to be I picked all these ones with 3 in the denominator. We notice that it is at 2 pi over 3 and 5 pi over 3 for between 0 and 2 pi. Then, of course, we need to find between negative 2 pi and 0. So subtract 2 pi from each of these. Your answers are negative 4 pi over 3, negative pi over 3, and then 2 pi over 3 and 5 pi over 3. The last thing is to determine whether the function is even, odd, or neither. We're going to verify the answers algebraically. So just remember, in order to verify whether something is even or odd, we plug in negative for x. So for example, when we plug in negative x into the function and we get the exact same function back, the signs are all the same as it was originally, then it is even. Now if we plug in a negative into the function and all the signs are opposite, then it is odd. And then if it doesn't work out, then if it's neither perfectly the same or perfectly opposite, then it is neither. So for letter A, let's try this out. We're going to plug in f of negative x. So we're going to plug in negative for all the x's and see if it changes. So negative x, that stays the same. Tangent, so that is odd, so we know that it becomes negative tangent of x. So now we look at whether or not the signs are the same or opposite. So it's positive, positive, and now we plugged in a negative x, it's negative, negative. So therefore, this tells us that the function is odd. Therefore, this is odd. So try out this example down here. Determine whether it's even, odd, or neither. Verify it algebraically, please. So if you try this out, you plugged in a negative x, so you have to remember that cosecant is sine, and then remember sine is odd. So therefore, if it's a negative inside, then negative gets factored out. It's negative cosecant of x. Then that multiplies to the negative that's already there. So therefore, you get x cosecant of x. You get the same function back, g of negative x, just equals g of x. So therefore, this function is even.